Hello guys, today I'm going to share with you about the normality assessment using the epidemiological and biostatistic applications. So this is a very brief explanations. Hope it will be benefit to all of you. So this topic will be covering as follows. This is our objective of the study. So if you can see here, we are going to list down the type of the normality tabulations, and then we are going to define and also to count the Z calculations, which is will be explaining after this. And then we want to know the probability of the observations, whether the two measurements are within the normality standards or not. And then we are going to understand also whether the observations is within or not within our hypothesis levels of understanding. So as a start, for your information, there are a few types of normality assessment that you need to understand. The first one is about the symmetrical shape of it. So if your data is symmetrical, like a bell shapes, so we can call it as a normally tabulated. And then we are going to look into the skewness also, whether it's skewness positively or skewness negatively. And then the very important items is the the tabulations of the scale data or the numeric data is very important for us to identify whether we can use or not use the parametric or non-parametrics analysis in the further hypothesis testing. And then for the applications in our examples during this course, I'm going to share with you some of the ideas about the normality tabulations using the scale measurement, for example, height, weight, and also IQs. Okay, this is the example and typical explanations about the normality tabulations. So first of all, we need to know that the tabulations containing a simple curve, which is the one curve inside the middle of the data, and then the mean, mode, and median is will be arranged not into accordance of the specific center. However, as long as the designs of the tabulations are within the shapes of the bell, so we can call it a symmetrical element, and therefore it's come out to the another ideas, we call it as a normality tabulations. And then both of these normalization is not touching the x-axis. In the additional mathematics before, we learn about the asymptote, whether the curve that already been flattening on the x-axis is actually not touching to the x-axis. So this is the example and the typical explanations about the normal distributions, if you can see here. So the curves are symmetrical to each other. If you draw a simple line here, we can see that this line is actually produce similar projections of the space here and this space. So the mean, mode, and median will be in the same spot. So that's why we call it as a normally tabulated. So if if we can see the tail of it actually go into this side of the area, we call it as the positive skewed, and then if go in the other direction, we call it as a negative skewed. So this one is not touching the x-axis because it is called asymptote. Okay. All right, so now we are going to see the differences between the standard deviations and also the design of your tabulations. If you can see here, the lesser part of your standard deviations will make your tabulations much more higher in terms of the peak. If you can see here, the standard deviation is 1. So how the standard deviation is 1 is actually measuring from the dispersions of the data using the signs of the standard deviations here. So if the signs is around 1 from the center of the data into the tabulation manner of it, for example, in this case we call it a plus minus 1. So we can see the tabulations have the highest peak as compared to the next one will be the standard deviations 5. So the standard deviations 5 will be the lower one, and then the last but not least is the standard deviation 10. The standard deviation 10 indicate that it's much more flattened as compared to the standard deviation 1. So you must understand that each of these curves are representing by the shape of it. Yeah. Even though it is called anomaly tabulated, you must also need to understand about the peak. If the peak are higher in terms of the tabulations of the data, it is normal, but you must also get some ideas where the standard deviation is low in terms of the spreading from the center of the data. Okay, this is the example of the mu and also the sigma that associated with the design of the tabulations. Okay, I'm going to remove this video. So you can see here, this is the normal tabulations. This is about the mu is equal to -2, the sigma is equal to 1. So what is the mu and sigma? So as you learned before, the mu about the mean tabulations, and whereby the sigma is actually explaining about the standard deviation, the dispersions from the center itself. So this is the mean of the data, and then this is the standard deviation of it, which is considered 0.5 plus minus. So this is another one, another case, typical case, which is the standard deviation will be 9, and then the standard the mean is 9, and the standard deviation will be 2. So as long as it's tabulated using the mean and standard deviation, you must clearly by now that it will influence the patterns of the data. Okay. So now we are going to move to other understanding. So in this one, I'm going to explain to you about the area under curve. So we call it as area under curve. So in this topic, you must understand that area under curve is actually considered normal if is equal to 0. So you have the tabulations of data like this. So anything that below this area under curve is equal to 0. So that is our assumption. So you must now transform your understanding about the assumptions of the data. Okay. So mathematically, we can say that 88% of all of these tabulations are normal, are actually within the one standard deviations, which is the plus minus from the mean. And then the other 95.5% is the second example, is actually fall within the 2 standard deviations of the mean. And then the last but not least is 99.7%, which is the 3 standard deviations plus minus from the mean. So what is it all about? So if you can see this example, the first example here, we have 68% of the area under curve, and then the other 16% are being explaining within the outsides of the one standard deviation. So this one is also the same, explaining on the left side. So this is the negative side of the data. So this is the positive side of the data. So this is the assumptions that you need to understand. So the total of all this area under curve is equal to, correct, is equal to 1. So now, if we are talking about the second standard deviations, we are concerning and also focusing about the 22.25%, which is both directions on the positive side and negative sides, which is if we accumulate all of these, it will equal to 100%, or we call it as 1. So this is what mathematical models explain by the tabulations area under curve. So you have 95.5%, and then you got the excess one is approximate to 2.25%, which is if we divide by 100%, we got 0.025. Okay, so the last but not least is actually the 97% of the area under curve here, with the estimations of the axis at the 3 standard deviations from the center of the mean. We got the excess part of it will be 0.15, which is if we plus the 0.15 with the 0.15, we got 0.3, which is equivalent to 100% after we add to the area under curve that within the 99.7% of the areas. So this is just to give you some ideas. If we see the mathematical models, or if we translate these tabulations of normality curve, it's all about talking about area under curve, whether our data is within area under curve or not within area under curve. Okay, so we are going to the next chapter. We call it as the standard normal tabulation. Standard normal tabulations is actually a family of the normal tabulation data, which is approximately relies on the mean and also the standard deviations of the data. So we are going to use a lot of information from the mean and standard deviations to compute the standard normal tabulation. So it's differ from the normal histogram that you produce based on the raw data. This one is more on the we converting it into the value of the standard deviations. Value of the standard normal tabulations. So if you can see here in our explanations in Malay language, we can see that all these things can be derived from different manner. As long as we know the standard deviations, as long as we know the mean of the data, then we can create and assume the tabulations of standard normal tabulations. So the standard normal tabulations will have the ideas of the mean is equal to 0 and the standard deviation is equal to 1. So for this standard normal tabulations is being explaining by the symbols of x, or we call it as also as a z-score. So this one you must remember because it will associate with the mathematical formula that I'm going to explain after this. Okay, so basically taburan normal piawai ini is actually a taburan normal yang kita assume from the tabulation yang menggunakan konsep standard deviation dan juga mean. Okay, so we are going to discuss also about the characteristics of the standard normal tabulation. So actually it's equal to 1, as I mentioned before, it's equal to 1. So the curve is actually not touching the axis of x because it got the asymptote element, and then the symmetrical element will be equal to the 0 on the mean, which is, we can call it as the center of the data, and then it will be the same on the left side and also on the right side. So this is the characteristics of the standard normal tabulation, so we call it as taburan normal piawai. So it is it's meeting the empirical theorems of the mathematical formula in the data analysis. Okay, so how you want to change the normal tabulations of data, which is the taburan normal biasa, which is you are using the histogram by accumulating every of your data according to a specific class group and so on, into the standard normal tabulation data. Okay, so it's very simple. So we are going to use one table, one established table by the statistician before. We call it as the jadual taburan kebarangkalian piawai, or we call it in the American language, which is the standard probability tabulation, standard tabulity expressions, or we call it as the normal tabulation standard, something like that. So because there are so many things that we need to consider about all these things, we have to understand about the formula that you can use to convert any of your x. So x is actually your variables, so anything that you want to convert into a z-score, or we call it as the area under curve in your standard normal tabulation tables, which is I already called just now is a specific tables. So we can use this formula, z is equal to x, x is equal to our any data that associate with your variables minus by our mu or mean divided by the standard deviation. So this is the example of it, where x is actually anything that associated with your variables, but you must understand that your variables must be in a scale manner, and it's being chosen from the random allocations, and then mu is actually your mean, and then the sigma is actually representing your standard deviations of the data. So we can derive this mathematical equation into the other parts of it also. For example, if you want to know standard deviation, we got the z-score. So how you want to know the x, we can still calculate all of this. You just playing with the mathematical equation. Okay, so why we are using the z? So this is the interesting part that you need to clearly understand why we use z. So z is actually we are going to make everything in a standard manner. Okay, for example, I have money, I have weight, I have height. All of these are actually differ in terms of the scale. So how we want to make it as a standardized scales. So therefore, the z-score is very, very important for us to understand the scale in terms of their groupness, or in terms of their similarity. So we are going to convert every of these aspects into aspects of tabulation in the standardized tabulation. Same also goes to the other parameters that we measured. So this is why we use this z-score for our statistical analysis. So because of this standard tabulation tables is actually being used with the probability of the standards. So that's mean the Z symbols is very useful for us to graphically simulate how the data perform. I mean, if you talk about the height and the weight, so we can see whether the height and the weight are tabulated normally. Is there any association? Is there any relationship, and so on in the further explanations of the statistical procedure. However, you want to make sure that the scale are similar, but of course it's not. So how to make it similar? So we change to other standards. So that standards we are talking about the z-score. Okay, so this is the examples of the figures that explaining to you about the use of the z-score that you want to change into the specific axis in your normal data. Okay, I give you one example. So we have the data here. So this is normal tabulations of data, and then we want to convert this data into tabulations normal standard data, which is taburan normal piawai. So how we are going to simulate this thing? So the first one, we need to know that this is the center of it, which is the 50% of the 50% on the right, 50% on the left. Okay, that is the other story. The main idea is actually the mean is 50. So our standard deviation will be 25. So this is just a simulation to show you if the standard deviation is 25 and the mu or the mean is 50, we can calculate this thing to give some ideas that the z is actually equal to 1, correct? So if you use x is something's 75, for example, we take the 75 on the x, we minus the mu of the 50, and then we divide by 25, we get 25 over 25, which is equal to 1. Similarly, if we talk about the negative side of the data, for example, we have the data that's skewed on the left of our data. We got the x is equal to 25. We minus 50 based on the formula z is equal to x minus mu divided by standard deviation. We got negative 25 over negative 25. We got x and negative 1. So this is the typical ideas how we want to convert any data that you have into the z-score of the data. Okay, so how these tabulations of data are actually explaining everything into one group. So this is why we are talking before about the normal tabulations of data, but we want to convert every items of it, because this is represent the money, this is represent the height, this is represent the weight. So I want to make sure that everything come into one piece. So how we want to do it? So of course we need to do using the standard normal tabulations data using the z-score. So how are we going to do that? Yes, we transpose everything into this formula. Z is equal to x, which is our data, minus the standard deviation divided by the, minus the mean divided by the standard deviation, and then you will get these tables simultaneously. Whatever differences here in terms of your raw mean and also your raw standard deviation based on your specific parameters, it will still give and derive the similar pattern of your tabulation. Why? Because it's being standardized into a specific grouping. We call it as a z-score, and then it will also cover under the standard normal tabulation table, which is, I'm going to show you the table after this. So this is the example of the data, so you can have a look first and understand a little bit, and then we will discuss this thing after this. So we have 14,000, and then we have the standard deviations is equal to 1005. So if we simulate the data, we got something like this, 14,000 in the middle, and then we got the standard deviations is plus minus 1,500. So the question asks you, what is actually the tabulations of data if the salary is equal to 16,000 on the normal tabulations data. So therefore, you need to use the formula, and then we got the z is equal to plus minus, we got the z is equal to 1.33. So I'm going to share with you this formula after this, so stay tuned.